Hello students. So today in this video we are going to discuss about vectors, basics of vector. Because before we start motion in two dimension, we need some ideas about how to deal with vectors, right? So let us start vectors. Basics of vectors. Okay, so what topic we will understand here? So first of all we will understand what is vector, types of vectors. Okay, so first of all we'll discuss about what is vector. What is a vector? What is a vector? So in physics there are different physical quantities. Some physical quantities can be explained or understood without direction. Only magnitude is sufficient. But some quantities which are vector, they need magnitude as well as direction. Also there are certain laws by which we treat vectors. So vectors are those physical quantities, those physical quantities which requires both magnitude and direction, and they follow certain laws. These laws are called vector laws, which we are going to discuss here, okay, in this chapter. Vector laws. So there can be some quantities which have magnitude, direction, but they do not follow vector laws. Okay, so we can take first examples of vector quantities: displacement, velocity, acceleration, force. So many such quantities are there which will require both magnitude, direction, and they will follow certain laws. But there are quantities which do not follow laws, vector laws. Okay, so certain quantities are there. Example you take. Example of such quantities is like moment of inertia. Another example, if you take current. Okay, these quantities they have magnitude, and they also have direction, but they do not follow vector laws. So that's why they are not vector quantities. Okay, they are not the vector quantities, right? So some of them are like scalars, like current is considered as a scalar quantity. Scalar quantity. Moment of inertia, they are also treated as scalar quantities only, right? But there are some quantities which are like tensors. Tensor is a different category of quantities. They have magnitude, direction, and they will be treated in different manner. They don't follow vector laws. Okay, but they are not categorized as scalar. Okay, but current is not tensor. Okay, tensor is out of syllabus, so that thing we are not going to discuss here. Okay, in engineering you will be learning that. Okay, so let's not go into most detail about mass, because those are parts of mass. Okay, let's go to next. So what are the different types of vectors? Types of vectors. So first thing is we have null vector. Null vector means it has magnitude is 0. Magnitude is 0, and it has direction is there, but direction is not definite. Okay, direction is not definite. For example, if I say velocity vector is 0, vector is represented by the arrow symbol over this symbol, right? V. So this is velocity vector is 0. 0 should be written as 0 vector, not just 0. Okay, if you write just 0, then that looks like just the magnitude. Okay, 0 vector, it's having a direction, but although the direction may not be definite, right? Okay, for example, suppose somebody has a displacement of 0 meter in east, 0 meter east, 0 meter west, everything is okay, but it cannot be definite because there is no magnitude, right? This is null vector. Then unit vector. Unit vector is a vector whose magnitude is 1. Magnitude is 1. So suppose, for example, if you have to take a unit vector, so representation of unit vector is like cap. Okay, suppose this is velocity vector, but it's a unit velocity vector. Okay, so this will represent a unit velocity vector. Similarly, if I write a cap, that can represent unit acceleration vector. So unit vector is represented by a cap over its arrow, and there are standard directions which is represented x, y, z. Okay, so if you take x-axis in this direction minus I cap, negative x-axis minus I cap, positive y-axis y direction is j cap, negative y-axis is minus j cap, positive z-axis is k cap, negative z-axis, right, is minus k cap. So these are just representing the unit vectors along this direction. For example, if I say the velocity of a car is, let's say 2I cap. So the car is going in with a velocity 2 meters per second along positive x-axis. Understood? So this I cap, j cap, k cap, they just tell about the direction, right? Magnitude will be 2, but direction is I cap, means along x-axis. Okay, these are unit vectors. So a unit vector is represented, let's say any vector is r vector. This r vector is represented as magnitude and r cap. Okay, so r represent here magnitude, and r cap is unit vector. So from this definition, r cap will become r vector by r. Okay, this formula we should remember. Unit vector is the vector divided by magnitude, right? Then there are vectors which are like vectors, like and unlike vectors, So what are like vectors? So two vectors in the same direction are like vectors. Unlike means they are opposite, that means anti-parallel. So parallel vectors and anti-parallel, you can see anti-parallel. So that means they will be opposite. Okay, that's what is like and unlike. So if they are like vector, suppose this is a vector and this is b vector, so a vector will be k times of b vector. Of course here k has to be positive, because then it is in the same direction. But if it is a vector k times b vector, here k must be negative. So then only they are opposite. Okay. K is a scalar here, of course, numbers. Okay. Then what else? These are some vector quantities, right, that we deal with. Now let's understand position vector. Position vector. So we have the x, y, z, right? X, y, and z coordinate system 0, 0, 0. So any point if you see, it will have x, y, z, and you can join this, right, like this, and you can draw arrow like this, because this will be representing the position of that, okay, joining from the origin to that particular point. This vector represent position vector of that. And how this is written? This position vector is represented as xi cap plus yj cap plus zk cap, because I cap, j cap, k cap are in x, y, z coordinates, right, directions. So what is the magnitude of this? Magnitude of r is x square plus y square plus z square. Also you should note that the angles which the vector can make, alpha, beta, and gamma. Okay. So alpha, beta, gamma are the angle made with x, y, and z axis, right? So here we can calculate cos alpha, which is x by r, cos beta, which is y by r, cos gamma, which is z by r, and this is also known as LMN. Okay, and L square plus m square plus n square is equal to 1. So LMN are what? They are called direction cosines. Direction cosines. Okay, because they are representing angles alpha, beta, gamma. Okay, these things are important here. In position vector we should not represent this. And similarly, if I have to write r cap, so a unit vector along the direction, because along that direction there can be unit vectors. Along this direction there can be unit vectors. Okay, so this unit vector r cap can be represented as the vector r by magnitude. So if you divide this is xi plus yj plus zk divided by r, you will see that x by r, it will become cos alpha I cap, cos beta j cap, cos gamma k cap, which means it is li cap, m j cap, and k cap. This is what is r cap. So unit vector can be represented in this manner. Okay, right? So there are various types of vectors can be there. More can be there, but let us focus on this, not going into more in details, because as far as main is considered, we can work out questions with sufficient this knowledge. Then let's move to the next. Now we should know about representation of a vector. How do we represent a vector? So it's a vector quantity, so there is a graphical representation. So on graph, right, we can represent it. So let us say we draw the graph like this. On a graph paper we can represent like this. So this point from where it is starting, that is called tail, and this point where it is ending, that is called head. The distance between head and tail, this line, length of the line, that is the magnitude. And direction is from tail to head. Tail to head gives the direction, Of course, when you are plotting on a graph, you will have to give the direction based on standard, direction. So suppose this is a positive x-axis, no? So suppose this, vector is in a plane, xy plane, right? And you have to draw this vector at an angle of theta. So there will be some angle theta. Theta will represent direction. Theta is measured from positive x-axis. Okay, and in this direction theta will be negative, and this direction theta will be positive. Right? That means if you measure theta in anti-clockwise direction positive, clockwise direction negative. Okay, right. So this is the magnitude which you can represent as r also, and this is the theta. Okay, suppose if I have to represent on a piece of graph paper a force of 10 Newton towards 30 degree east of 30 degree at an angle of 30 degree north of east. So first of all I should have idea of this. This is east, this is west, this is north, this is south. So if I have to represent a force of that 30 degree, this is, let's say, first of all we will make a force representation by a line, right? So this is 30 degree angle, and the length of this line can be chosen according to a particular scale. Some scaling can be done. Let's say I make 3 centimeter and it will represent 30 Newton. So I can just make 1 centimeter line that will represent 10 Newton. Okay, so scale will be on the graph paper, scale will be 1 centimeter will be 10 Newton. Okay, so I have to draw only 1 centimeter line on the graph paper at an angle of 30 degree with the horizontal, right? So like this graphical representation we should know, and we should know that this can be slide. That means this graph can be moved here and there. That means this is called free vector. So we should know free vector and fixed vector also. Free vector. What is a free vector? Free vector means, suppose if I draw a vector like this, okay, so now I can slide it anywhere like this. For example, let us take, I have slide here, anywhere parallel to itself I can slide, isn't it? So nothing is going to change. Only thing that will change is the location of the points. That means, let's say here this tail is here and this is the head here. Now the location of tail can be here now and head will be here. What difference does it make? Nothing. The direction is same and this length is same, magnitude is same. We have just moved the whole vector itself. So such are free vectors. We can do fixed vector means it will be acting at a point itself. Tail you cannot move, but here we can slide it parallel to itself. Okay, you can slide the vector parallel to itself, or you can say you can translate it parallel to itself. You cannot rotate. If you rotate, the direction will change. Okay, or if you stretch it, if you change the magnitude, then also it will change. So we are not changing that, right? Now let us understand vector addition. We'll see vector addition. So vector addition, there are many laws, first, second and third. So triangle law, parallelogram law, and third is polygon law. So let's discuss triangle law first. So triangle law of vector addition. Triangle law of vector addition. So two forces or two vectors can be added. Let us say that if this is one of the vector like this, and let's say if this is another vector like this, we need to first of all bring tail and head together. So this is the tail, right, and this is the head, and this is the tail of the second, this is the head of the second. Okay, so this is, let's say, A vector, and this is, let's say, B vector. Okay, so the tail and head of these vectors should come together. That's why this is called tail head method or head tail method. Okay, so you should join these two vectors like this. Once you join these, you should try to join the tail of the first with the head of the second, like this. So this vector represent A vector plus B vector. Okay, this vector represent A vector plus B vector. This is the sum of or resultant of the two vectors. Okay, this is triangle law. So we should see that we should join the tail of the first with the head of the second. Then the third side, that represent the resultant sum of the two vectors. Okay, now here we can try to find out the values of this. Okay, let us try to do that. Okay, so let us extend this one like this. Let's say this is the angle theta. Okay, here the one point comes, what is the angle between two vector? How to know? Angle between two vector is angle between their tail or head. Suppose two vectors are like this. This is common tail, right? This is common tail, both the tails are together. Then this angle is the angle between vectors. Similarly, if this is both the heads are together, common head. If heads are together, then this is also the angle. This is the angle between the vectors. Also, you should note that then this angle will be 360 degree minus theta, and this also will be 360 degree minus theta. Now here we should choose minimum of the angle. Okay, so out of theta and 360 degree minus theta, we have to choose minimum of these. Minimum of these two. So minimum of these two is the angle between the vectors. Okay, that's what it is. Now here, coming back to this, this is theta. So what we can do is we can drop a perpendicular from the top. So this length is B, this length is A. Okay, so this will become how much? This will become B cos theta. And how much will be this? This will be B sin theta. Okay, and now you can see here that of course this is the point which we are taking. So let us now try to join. First of all, try to make this bigger triangle. This one, right? And the resultant is this one. So let us find out, and this is a 90 degree right here. So let us find out this resultant. Magnitude will write as R. Okay, so R will be how much? So from here to here, this is A. So this total from here to here, it will be A plus B cos theta, isn't it? From here to here, this become A plus B cos theta. So in the bigger triangle, R is root under hypotenuse now. So A plus B cos theta whole square plus B sin theta whole square. So when you open this, then you get this formula, root under A square plus B square plus 2AB cos theta. This is how we find out the resultant of two vectors, the magnitude of resultant. Okay, this is the magnitude of resultant. Now if you want direction of resultant vector, so direction means this angle. This is the resultant making angle alpha with first vector. Okay, so this tan alpha, from here we can calculate tan alpha is b sin theta by a plus b cos theta. Okay, so this is how we can find the angle between. Suppose if you want to find the angle of this vector with b, that means suppose you want to find this angle, which you can say as beta. So same manner you can do tan beta. Tan beta will be just a and b replace. Okay, it will be a sin theta by b plus a cos theta. Just replace the a and b. Okay, this is how we can calculate tan beta. So this is a triangle law of vector addition. What is parallelogram law? Second, parallelogram law. Parallelogram law. So parallelogram law means we have to put the common tail. Okay, tail method. That means both the tails should be together, or head can also be together. Okay, so suppose this is one and this is another vector like this. Okay, so the angle between them is theta. This is, let's say, a vector, this is b vector. So they should be joined together. This is a common tail. Both of them tail is together, common tail. Then at this point you try to draw a parallelogram. Parallelogram like this we draw. Okay, so the the diagonal of the parallelogram, this is what is the diagonal of parallelogram. That diagonal will represent the resultant vector sum, which is a vector plus b vector. Okay, and it can be making angle alpha with one and beta with second. All this thing is same, right? Only thing is the diagram is different. All the formulas are same only. So the magnitude of resultant will be same as root under a square plus b square plus 2ab cos theta. The tan alpha will be b sin theta by a plus b cos theta. Tan beta will be same manner, a sin theta by b plus a cos theta. Right? These are the things that we should know. Parallelogram law. Right? Then next is polygon law. See, in the triangle law and parallelogram law we are adding only two vectors, but polygon law we can add n number of vectors, and it's a general approach of triangle law. Okay, so this is suppose one vector. Okay, let us say this represent one vector. Then we should try to bring the head and tail together. This is another vector. Let us say this represent another vector. Let us say this represent another vector. So these are different vectors, and try to join the tail and head together. So this is, let's say, a vector, this is b vector, this is c vector, this is d vector. Four vectors I have tried to join the head and tail together, like head here, head of a and tail of b is coinciding. Similarly, head of b will coincide with tail of c, right? So head of c will coincide with tail of d, like that. And this is the head of d, and this is the tail of a. So finally we should locate the tail and head and try to join them, but the direction should be in opposite, right? So you can join it like this, the direction going from the tail of the first to the head of the last. Okay, like that will represent the resultant vector. Here the resultant vector is representing a plus b plus c plus d, right? Because four vectors we have taken. So like that, any number of polygons we can do that. That's why polygon law. That means n number of vectors are there. You try to make a polygon, the closing side, the last closing side going from tail of the first to the head of the last vector, that will be the resultant vector. Okay, that will represent the resultant vector. Of course, this is a method to draw, on graph paper. Here there is no need to calculate any formulas and all that. Okay, it's a graphical method basically, right? Okay. then we will understand important thing that is called resolution of a vector. Resolution of a vector. So suppose there is a vector like this. Okay, this is a vector. Now this vector is making some angle with x-axis. Let us say it is making some angle theta. Theta angle it is making with x-axis. This is positive x-axis, and we are taking it's like a 2-dimension 2D vector. First let's take 2D vector. So if you drop a perpendicular from this, let's drop a perpendicular. So how much will be this? Let's say this magnitude is r. So from here to here this magnitude will be r cos theta, and this magnitude will be r sin theta. This is called resolution. Okay, so the vectors can be resolved into two components. One is along x-axis, one is along y-axis. These are resolution into perpendicular components. Okay, resolution of a vector into perpendicular components. Perpendicular components. Okay, they are perpendicular components. So if this is r vector, so component means it's also a vector only. So we can draw that component like going like this and another going like this, and this you can say that this is r which is along x-axis, rx, this is ry. So you can write this r vector is rx vector plus ry vector, and both are perpendicular. So you can say its component rx is along I cap and this ry is along j cap. Now what is this rx? Rx is r cos theta I cap, and this is r sin theta j cap, right? So now here we can take r common, and it will become cos theta I cap plus sin theta j cap. Okay, and this r into this is what is called r cap. So that r cap is representing a unit vector. Okay, unit vector. So unit vector along this direction, a unit vector can be represented as cos theta I cap plus sin theta j cap. Okay, a unit vector in any direction can be only theta should be known. That's all. So we can write. This is of course in 2 dimensions. In 3 dimensions we have already seen cos alpha, cos beta, cos gamma. That also we can write. Okay, right? So in 2 dimensions we can do. So we can resolve a vector into 2 perpendicular components. Right? So this is the resolution. This is a very important concept because we can add n number of vectors by representing into components. Let's take example. Suppose this is r1 vector, this is r2 vector, this is r3 vector, and all of them you have to add. Let's say add. This is the resultant vector. Let's say r vector, net vectors. Okay, net vector, sum of all. If you want, you can just write capital R, because capital R is the resultant r vector. So here this r1 means r1, let's say it is making some angle theta 1. Okay, so you can write this as cos theta 1 I cap plus cos theta sin cos theta 1 and then sin theta 1, right? Sin theta 1 j cap. Similarly, Second one can be written as R2 cos theta 2 I cap plus sin theta 2 j cap. Like that you can continue, n number of factors can be added. Okay, like that you can do. So then I cap you can club together and you can bring sum of R1. This R1 means you can take this as Ri, or let us say some other symbol you can write. Okay, let us say Rx you write here, Rx cos theta x, cos theta x. Okay, where x is going from 1 to n. So this will be like the summation of x component. Same manner we can write summation of, let's say this is y. Y is going from 1 to n, and this is ry sin theta y. Okay, and this is j cap. So we can club this like this, isn't it? So n number of vectors can be just easily calculated like this manner. Okay, so these are important things. Then these are addition. What about subtraction of vector? Subtraction of vectors. How do we subtract two vectors? Subtraction is also another kind of addition. Okay, let us say that there are two vectors which you want to subtract. This is one vector, A vector. Let's say this is B vector. The angle between them is theta. So what is A vector minus B vector? It is nothing but A vector plus of minus B vector. So when you are doing this, we can take minus B vector, which is just the opposite, and then this angle becomes 180 degree minus theta. So basically you are going to add these two and you can apply parallelogram law, and then this will be the resultant vector. This vector represent A vector minus B vector. Okay, A vector minus B vector will be represented by this. So the magnitude of A vector minus B vector can be calculated as root under A square plus B square plus 2AB cos of 180 minus theta. So cos of 180 minus theta will become minus cos theta. So this will be A square plus B square minus 2AB cos theta. This is how we calculate. Okay, and same manner the angles also can be calculated. Suppose this is making angle alpha with x with first and beta with the second. So tan alpha will be calculated as B sin theta, right? So B sin, so sin 180 minus theta you have to write B sin theta by A plus B cos, right? So here you will see B sin 180 minus theta is same as B sin theta, so this will not change, but cos 180 minus theta, that will become minus cos, right? So A minus B cos theta. This is how it will change. Similarly tan beta if you want, so it is B, instead of B it will be A and B will interchange, right? So it will be A sin theta by B minus A cos theta. This is how we can calculate this. Same thing, right? Okay, this is subtraction of vectors. Then we should know other operations which are called dot product and cross product. With these two we will complete this. Okay, so dot product of two vectors. So suppose we have a vector A vector and we have another vector B vector. The angle between them is theta. So what is the definition of A vector dot B vector? It is defined as the magnitude of A into magnitude of B into cos theta. This is the definition, and the result is a scalar. So it is also known as scalar product. Scalar product. Why scalar? Because A into B into cos theta, there is no direction associated with it. Okay, this is the definition of this. Now one thing to note is that what is the physical importance of this, right? Lot of physical importance with this. So let's first understand what is the physical meaning. So A dot B, I can club B cos theta together, and B cos theta is nothing but the component of B along A, because when you draw perpendicular, this is the resolution part of B along A, right? B cos theta. Of course, this is A. So this length is B cos theta, this is A. So you are multiplying A with B cos theta, right? Which you can say as the component of B parallel to A. B parallel. This you can represent as B parallel, and this component you can represent as the perpendicular to A. So A into B parallel, product of these two, represent A dot B. Similarly, we can also represent A dot B as, this time we can club A cos theta together, and then this will be B. Now what will be A cos theta? Let me just redraw this diagram. Okay, so if I take this as A vector and this is B vector, now I will draw perpendicular from A to B, right? This component along B, that is A parallel, and this part is A perpendicular. Okay, so and the total length this side is this length B. Okay, so what is A parallel? Because this is theta, so A parallel is nothing but A cos theta, and A perpendicular is nothing but A sin theta. Sin theta component we see other, but A cos theta can be written as A parallel, and this is B, right? So that's the meaning of the dot product. It is the product of component of one vector along another vector into the magnitude of another vector. Okay, that's what it is. This is just the product of two things. One is the component of first vector along another into the magnitude of another. Of course, this can also be written in terms of vector, right? We can also write, because vector has directions. So suppose if you want to write, for example here, if you want to write B parallel as a vector, so B parallel vector magnitude of B parallel into direction is along A, so A cap you can say, so that will become B cos theta A cap. Okay, and A cap can be written as how? A cap A vector by A, right? Like this you can write. Similarly, how do you write then B perpendicular? Because sum of B parallel plus sum of perpendicular, that is what is B vector. So from here, B perpendicular can be calculated as B vector minus B parallel vector. That already we have calculated, right? B vector is already given and B parallel we calculated. Same manner for A parallel also we can do. A parallel is component of A along B. So this will be A cos theta B cap. Then again A cos theta B cap means B vector by B, right? The same way A parallel plus A perpendicular is A vector. So from here we can understand that A perpendicular will be A vector minus A parallel vector, and parallel vector we have calculated. Okay, this is the physical meaning of that, and there are a lot of applications going to come on dot product. Some applications we can see, applications of dot product. So the application of dot product is like work done. Work done by a force is the force into displacement vector. Okay, so here suppose if a body moves from this point to this point, this is position vector 1, this is position vector 2. So first of all, this is called displacement vector going from 1 to 2. Okay, and let's say force have been acting in a different direction. This is the force vector, assuming it's the constant force. So the work done by the force is given by this. And if the force is variable, here of course force is constant. Force is constant. If force is variable, then you have to integrate this F dot dr vector. Okay, this formula we should use when force vector is not constant. Okay, this formula we use in that case. So similarly, there are many quantities you will be seeing gradually as the chapters you will be going through, right? Then let's go to the next, cross product. Cross product of two vectors. Cross product of two vectors. Cross product of two vectors. What is cross product? So cross product is defined in the same manner A cross B as A, B sine theta, and there is a unit vector, unit normal vector. So for this we have to understand properly what it is. Let's say that this is A vector and let us say that this is B vector, and the angle between them is theta. So we need to apply right hand thumb rule and we need to draw diagram like this. Let's say that this is the right hand thumb. Okay, this is right hand. So as you are curling your right hand from A to B, you have to turn from A to B. The thumb is pointing in this direction. So the direction of A cross B is perpendicular to the plane of A and B. Okay, it is perpendicular to both A and B, right? And here you need to note that this is of course right hand thumb rule. Right hand thumb rule. Right hand thumb rule. Okay, so now you need to note here that what is n cap? N cap is in this direction. N cap is a unit vector perpendicular to the plane of both A and B. So A cross B vector is going to be perpendicular to both A, and A cross B is also perpendicular to B, right? That's what it is. This is what we have to know. And what is the physical meaning of this A cross B vector? The magnitude of A cross B vector, magnitude of A cross B is AB sine theta, right? So this AB sine theta will give us the area of the parallelogram formed by A vector and B vector. So this gives area of parallelogram formed by A vector and B vector. Okay, that's the application. Even triangle area can be considered, but triangle will be half of this, right? We can calculate that also. But that's the main thing here, cross product. And how to do cross product, dot product when the vectors are given in terms of I, J, K, right? That we have to see. So let us see A vector is, let us say AX I cap, AY J cap, AZ K cap. Okay, and this is B vector in terms of component BX I cap, BY J cap, BZ K cap. So if I have to take A dot B, remember when you take dot product, you should only multiply AX BX, AY BY and AZ BZ. It is so easy, right? So dot product taking is very easy because you need to just multiply the coefficients of x, y, z, z. Okay, but cross product, A cross B may not be so easy. For that we have to apply matrix method. We write ijk like this and then write ax, ay, az. Then write bx, by, bz. Then what you do, how do you expand it? You write first I cap, then minus j cap, then plus a cap. Okay, like this you write. Then we can fill these places. So first you need to hide, this and this. Okay, then what is left? What is left is this only. So ay into bz and az into by. So this will be ay bz minus az by. Okay, once you write this, same thing you have to repeat next time. You have to cover up this one. Okay, so when you cover this one, what is left? Then we have to left ax and bz and az bx. Okay, so it will become ax bz minus az bx. And the third time when you are going to do, you have to leave this one, this row, this column, right? So this time which one you are going to do, right? You have to take then ax by, ay bx, ax by minus ay bx. Like this. Once you write this, after that game is over, because after that you can calculate magnitude of a cross b and everything can be done. So up to this cross product you should know, because once you know this, then you can do calculations, right? This is just the very basic we have discussed. Okay, so I hope you have understood all these basics. Then problems will discuss, then things will become more clear, right? Thank you for your attention.